Hi everyone, I hope you are doing well. So in today's video, I'm actually going to go through the 2018 Specialist Maths Exam 2 Multiple Choice section. Like always guys, before I start this video, if you guys want private tutoring in specialist methods, physics or chemistry, you can always email me through this email. And yeah guys, let's smash through this video. Question 1. Part of the graph of y equals half tan inverse of x is shown. Okay, the equation of its asymptotes are what? Okay, so we know that for an equation like tan inverse of x, let's call it y, equals tan inverse of x, we know that the range is between negative pi over 2 to pi over 2. And this is written in your formula sheet. So, okay. And what they've done here is think. They've just dilated by a factor of half parallel to the y-axis. So what they've just done is, imagine they put a half here. They multiply this by a half. And so what does that mean? You multiply the equation by a half. And this is the same equation as we have. So what happens to the y values? They pretty much just get multiplied all by a half. So if I multiply all those values by a half, what happens is this becomes negative pi over 4. If I multiply by half. And this over here becomes pi over 4, pretty much. Hence, what is your range? Well, your range is going to be from negative pi over 4 to pi over 4. Nice and easy. And you want to write those down. So like, y equals negative pi over 4 would be here. And y equals pi over 4. Nice and easy question. If you are confused, for example, you're in an exam and you're like, oh my God, I don't know which one it is. Just, what you can do? Just graph it. For example, let's try this. If I go on my graphing calculator and just go here and say, let's, half, so 1 over 2, let's graph 1 over 2, tan inverse of x. We graph it, yeah? And start, okay, go on relation. Okay, let's try to check the first case. A, it says y equals like 1 over 2 or y equals negative 1 over 2. Let's try that. Y equals, 0.5 or y, you look at this, straight away you know that's wrong because it would have, it's pretty much crossing an asymptote. You get close to it, but you never touch it. So absolutely that's wrong. Try the other cases like, 3 over 4. 3 over 4. Very, very, could be 3 over 4, but have a look at this. So 3 over 4 looks actually quite good if I'm not mistaken. So you want to be careful with that. Is there any point of intersection? Have a look at the intersection point. Yes, there is a point of intersection. They are not supposed to be, pointing. There isn't supposed to be a point of intersection. So that's also wrong. Y equals 1. Also, you can, pretty much putting all those values, that's what you can do. But in our case, we said 1 was pi over 4. Did I write it right? Sorry, pi over 4. Okay, perfect. And is there any point of intersection? Absolutely not. We wouldn't get a point of intersection. So that is the correct answer. So for question 1, E. Nice and easy. Question 2. Consider the function f with this rule, f of x, that where C and D are all elements of all reals and C is greater than 0. The domain of f is what? Okay. We know that, let's say, first let's do it by hand, then we can do it by calculator. Just so, for example, this could be used in exam 1. At least you guys know how to do it. Okay, whenever you have, say, a function like, for example, let's say you have f of x divided by the square root of, let's say, g of x. The domain of a function like this is just the bottom function, g of x, must be greater than 0. That's the, to find the domain of this. So in this case, it's the same thing, where f of x is just, 1, which is a function 1, and g of x is this inside function. And what does that mean? To find the domain, the implied domain, we want sine inverse of cx plus d to be greater than 0. So not equal, but greater. That's great to know. So let's actually think about it. How does actually sine of x look like? Just basic sine of x. So if I was just graphing a sine of x graph. All right, so something like this. This is y and this is x. So sine of x would be, normally it's like this over here. This is how the graph looks like. Actually, let me try it nicer. and it has endpoints. And okay, what's happened here is that, remember, we're saying c is greater than 0. So imagine we solve the inside to see what translation it's gone to. So cx plus d equals 0. Hence, it will be x is equal to negative d over c. So it's been translated to the right. No, well, in this case, translated to the left. But remember, d is an element of all reals, so we can put it as negative. So it can go both either right or left. Let's pick right to make our life easier. So if we're going to the right, imagine that we're taking this whole graph and we're translating it negative d over c to the right. So imagine translating it like this, taking this, and let me take this little too, like this. It's translated that much, so this now is negative d over c. Remember, so it was 0, but now it's been translated, so that point is that. And that's pretty much the graph. There is no reflections, because c is greater than 0, so it's pretty much like this. And what about the implied domain of that? So what's happened to these domains here? Well, what is the endpoints? Well, that's easy because it is just c of x, so the inside must be between negative 1 to 1. Hence, negative 1 minus d, cx, 1 minus d, negative 1 minus d over c, x, 1 minus d over c. So this is our domain. So this part here, so this point over here is negative 1 minus d over c. And this point here is 1 minus d over c. Now, remember what we said here. The implied domain, the domain is where this graph is greater than 0. So anything that it's at the bottom, so this we're going to reject. Here, it's actually equal to 0. So imagine from negative, so this point, negative d over c, so negative d over c, we're not going to include it. And it goes all the way to this point over here, which is included, which is 1 minus d over c inclusive. That is your domain. And so which one does that look like? It looks like B is your answer for that one. So let's see how you do this in a calculator. For example, you're in an exam, don't do this method. I'm telling you, what I've just done here is when you're in exam 1, you need to think about the concepts. Pretty much this is what you want to do. But for example, your exam 2 and you see a question like this, very easy. You're just going to go to your calculator and you're going to write domain of, write the function 1 over square root sine inverse c times x plus d comma x, given, you want to make sure, given that c is greater than 0. Enter, and we get the domain, which is this. Same as what we did. Easy. Next question. Which of the following, where a, b, and c, and d are non-zero real numbers, is the partial fraction form of this expression? Okay, so we have a very big expression here, so I think we can factorize it. Let's first factorize it. It's too big, pretty much. So, 2x, x, we'll call this 1, 1. So, how would this look? Is that right? So, 2x plus x. Looks good, yes. So, this pretty much can factor, the top part can factor to 2x plus 1. X plus 1, all divided by this expression over here. So 2x plus 1 to the power of 3. X squared minus 1 is a difference of perfect square, so we can write it as x minus 1, x plus 1. Now what can we do? Well, we can cancel that with that. We can cancel this, and this becomes hence 2. So this can be rewritten as 2x plus 1 squared x minus 1. Hence, okay, now it's much easier to kind of evaluate it in terms of partial fraction form. So what do we have? Well, we have something we have something that's squared. So when we write in partial fraction, we're going to have to write a divided by 2x plus 1. And it's going to make sure it's squared. The next case, it's going to be where it's not squared. So the same thing, but to the power of 1. So, and then plus c, where it's this one, x minus 1. Which one looks like that? It's not right? Looks like D is your answer, yeah? 2x plus 1, so 2x plus 1, A plus C. Yes, looks D. For example, if you're you want to double check your answer, you can do that using your CAS. Here's how you do it. What you just do is go on expand. You want to expand this whole thing. 2x squared plus 3x plus 1. 2x plus 1 to the power of 3 times. Oops. Sorry. Times x squared minus 1. Enter. So what do we see? This is in terms of, partial fractions. So you can see that there has to be an x minus 1. And it's just a basic constant. It doesn't have x's, so it's just perfect. So like a for this case. Whereas this one over here too, also constant. And it has to be written as 2x plus 1. And it's being squared, which we also have. And we also have this one. What about this one, last one? Yep, 2x plus 1. And we also have a constant. Great. So it is D. Question 4. If cos of x equals negative a and cotangent of x equals b, where a and b are greater than 0, then cosecant of negative x is what? So, okay, cosecant of negative x is what? So we can write that as 1 over sine. So 1 over sine of negative x. And we know that if there's a negative in a sine, we can get rid of it by putting it outside. So I'll put a negative 1 there. This is what we want. This is what we want to find. Now, what do we have? We have cos of x equals negative a, and we have cotangent, so which is just 1 over tan, which is b. If we reciprocate it, it'll become tan of x 1 over b. Perfect. And so we know that tan is what? Sine x cos x equals 1 over b. Hence, our cos in this case is negative a, so we can rub that out. Negative a, and then we can find sine of x. So we have sine of x. Now putting this into this expression, so negative 1 over negative a over b, so it would just become b over a. Well, the negatives cancel out, it's yeah. So it will be a in this case. Is that right? Negative 1, yep, and b over a. Perfect. Question 5. Let z be a plus bi, where a and b are elements of all reals except 0. If z plus 1, so z plus 1 over z is an element of all reals, which of the following must be true? Okay. Let's look at the first case. We have this. All right. So, wait. If this is an element of all real, what it means is telling us that when this expression is simplified, we want it to be real. So we don't want them to be complex. For example, like root 2 plus 3i. This is a complex because it has an I. What we want is for it to be all reals, we don't want to have any complex. So for example, we want it as root 2. That is a real number. So something like this. That's what they want us to do. Let's look at the first case. Argument of z is equal to pi over 4. Well, just from that, I know for a fact that there's already, let's say z is actually equal to 1 plus I. Now, if you don't know, 1 plus I has an argument of pi over 4. It's 1 over 1. So tan inverse of 1 over 1, it's pi over 4. Just from basic knowledge, I know that for a fact. So if I put it into this, so for example, so it will be 1 plus I plus 1 over 1 plus I. Multiplying this, so 1 minus I to kind of expand 1 minus I to rationalize it. So we get 1 plus I plus 1 minus I divided by 1 plus 1. So I, negative I squared. So yeah, which is 2. Hence 1 plus I plus half minus half I. Hence your final is 3 over 2 plus half I. Now this has a complex number, so it has an I, so this is not real, so this has to be false. A is false. Done. Let's look at the next case. This is how you need to think when you're doing in spec. A is equal to negative b. What we're saying is, let's say A is 1 in this case. Hence, b has to be -1. It's pretty much, this is what it's saying. So if a is 1, which is 1 here, is equal to negative of b, which is -1, which hence is 1 equals 1. So it does make sense. So if this is what we're taking the next case to be, a equals 1, let's write that down, a equals 1, b equals -1, and let's see if this works. So hence z is going to be 1 minus I, and do the same thing. So it's going to be 1 minus I plus 1 minus I times 1 plus I, rationalizing it, 1 plus I divided by 1 plus 1. So that will become 2. Hence this explain 1 minus I plus half I. Hence this whole thing just simplifies to 3 over 2 half minus 1, so -half I. This still has a complex I, so it's not real. That's good. Next case, A is equal to B, which in this case is like it's the same case as Z, but the one we said where Z is equal to 1, so 1 plus I, so A is equal to 1 and B is equal to 1, where A and B are equal, so that was also a case that was not right. Let's have a look at the next case. So the magnitude of Z is equal to 1, so in other words, your R value, which is the magnitude of Z, is equal to 1. So let's think about it. If I was like, let's say, if 1 cis, let's say pi over 4. It could be any angle, but I want to see if it's true. So 1 cis pi over 4 is what? So it's going to be cos pi over 4 plus I pi over 4. So sine pi over, sorry. It's actually just 1 over root 2 plus 1 over root 2i. Okay, so this is the case for this one. So that's your Z value. Great. Let's check if that works. So if Z is actually equal to this, would that be true? Let's check. So Z, so 1 over root 2 plus 1 over root 2i. Great. Plus 1 over 1 over root 2 plus 1 over root 2i times 1 over root 2 minus 1 over root 2i, all divided by 1 over root 2 minus 1 over root 2i. Okay, so 1 over root 2 plus 1 over root 2i. Alright, so that'll be 1 over root 2 in the top minus 1 over root 2i, all divided by half plus half, which is just 1. That cancels to 1, so it's just this. Hence, simplifying this, we get 2 over root 2, and these cancel out. Plus 0i. This one has no I. It's just a value of all reals. So this is great. D looks like your answer for that one. And so you can check it yourself. I think I took too long on this kind of question. But yeah, this is how you start to think in special. Start to look at it. If I put this, does this give me true? That's how you want to do questions. That's it. I'm going to put this like that. Okay. Next question. The complex number Z, IZ, and Z plus IZ, where C is a complex number except 0, are plotted in the Iguran diagram formatting the vertices of a triangle. The area of this triangle is given by what? So let's actually sketch. Let's start to understand what they're telling us. So let's nicely make a diagram here. The diagram can really show us what we need to find. Kind of like that. Okay? So what do we have? So let's say Z is here. So Z is this part here. This is Z. So we'll call this Z. Great. I times Z is when a Z is multiplied by I, it just gets rotated anti-clockwise by 90 degrees. For example, it would be over here. Oh, well, it's not, yeah, it's 90 degrees. It looks like it's 90 degrees. That's quite great. So, yep, so that will be here, IZ. And then the next one is Z plus IZ. So, okay, think of complex numbers as what? The best thing that I tell students is to think of them as vectors. So, what do I mean? Think of them like this. Think of it starts at 0 and it goes to Z. So, it's like this vector. And this is this vector. And what we're doing is we're adding both vectors. So, Z plus a ZI. So, what to do is imagine taking this here and putting it on top of this, like that. So when you put it on top, we're going to get something like this. This is now that green graph is your Z plus IZ. Great. So we have that and that. Great. Planar graph along the vertices of triangle. Okay. Have we done everything right? The area of a triangle is given by this. Okay, so now let's think. So have a look at this. Well, the area of a triangle, because it's a right angle triangle here, it's a right angle triangle. What do we know? Well, we just need to find this area of this triangle. Well, okay, if I know that the magnitude of Z is just called Z here, remember this magnitude, it's just Z. And this, they have to be equal to this also, because remember, when you multiply by I, it's just a rotation 90 degrees to the anti-clockwise, so it still has the same magnitude, so we could call it a Z. And so to find the area of that, remember this is your length and this is your height, so the area is half base times height pretty much. So your base is Z times your height, which is Z, hence your area is Z squared over 2. That's your area. Which one does that give us? Looks like C is your answer. Nice. A curve is described parametrically by x equals this and y equals that from 0 to 2 pi. The length of the curve is what? Very nice and easy question. So the arc length is very easy. It's just given, so length. When you have parametric equation, it's just going to be the integral from where do you want to go, from 0 to 2 pi. The square root of dy dt squared plus dx dt squared dt. That's all it is. So in this case, let's go on our calculator. And what we're saying is, okay, if we find the derivative of the, in terms of t for the x value, so like dx dt, it's just going to be sine of 2t. And it gives us this. And imagine squaring it. And it gives us this. That's your dy dt. That's great. Sorry, that's your dx dt. What about dy dt? Well, your dy dt is going to be the integral of 2 cos t all squared, so, and all squared. Perfect. And that gives us this. And imagine adding them together. So that added with this over here gives us this. And taking the square root of those, we get this. And then the integral from 0 to 2 pi of this in terms of t gives us 12.2 approximately. So C should be your answer for that one. Nice. Next question. Question 8. Using a suitable substitution of from 0 to pi over 6 tan squared x secant squared 2x can be expressed as what? Okay. If, I just saw, so if I let actually u equal tan of x, because I know the derivative of tan of x is secant squared, so that's great. What do we know? We know that hence dx will be 1 over, what's the derivative of tan of x? It's actually equal to secant squared of x du. So if I was rewriting this whole expression, if I sub it, well, I need to find the terminals. Terminals will change. So what's if I sub in, x equals 0, what's our u value? So tan of 0 is just 0. And if I sub in pi over 6, it is going to be 1 over root 3. So you remember tan is equal to u. So if this is tan squared, so it's going to be u squared multiplied by secant squared of x. And dx is 1 over secant. So 1 over secant squared of x du. Hence we can cancel those out, hence we get a final expression u squared du, which looks like easier answer. Nice and easy. Question 9. Let's look at it. A solution to the differential equation dy dx, this can be obtained from what? So what do we look? When we look at the answers, they're all separated, so they don't actually have the x plus y. So we're probably going to use our compound angle formulas. Okay, let's actually simplify the bottom here. Let's make it very nice. So sine x plus y, what's that? We know sine x plus y is just using your, it's just sine of x, cos of y plus cos of x, sine of y, and minus, let's move this a little bit, minus sine x minus y, which is going to be sine of x cos of y minus cos of x sine of y, which is just sine of x cos of y plus cos of x sine of y minus sine of x cos of y plus cos of x sine of y. We can see that these over here cancel out, hence we just get 2 cos of x sine of y. That's what it simplifies. And remember, so we can write that as dy dx. So it's like 2 over, so it just become 1 over cos of x sine of y. Nice and easy. So we can actually take this, sine of y, and just we can write it as 1 over sine of y. Hence, what do we know? Well, we're going to use separation of variables here. So we're going to integral. What's the thing that's in terms of y? And we're going to reciprocate it. So this over here, reciprocating it will be just sine of y dy has to equal the x value here. So it's going to be 1 over cos x dx. So which one would look like that? And we have to have a sine y. So this one has a sine y, and it's secant, which is, yes, 1 over cos of the x. So it looks like D is your answer for that one. Great. Question 10. The differential equation that best represents the directional field above is what? So normally you can do this in a CAS calculator like a second, but I want to show you how to really understand how to solve these by hand. So let's take a point. Let's say we take a point like, for example, we take this point over here. 0, so the point is 0, 2. And what do we see? What do we see at that point? We see that the gradient is actually around, like, it's positive. We can see it's positive because the gradient's going up. And yeah, so the gradient's positive. So let's have a look. If we sub, it means if we sub in here, the dy dx must be greater than 0. So if I sub it into this, let's think. If I sub in that, we get 2 over 2. Yeah, so 2 over 2, which is 1, which is greater than 0. So that gets a tick here. What about if here? So 0 plus 4y minus 2. This is negative, sorry. This is negative. B is wrong. What about C? So minus 2, 2, 2. This is also negative. That's wrong. Next case we can take is this. So 0 minus 4y over 2 minus pretty much 0, which is, what do I write y here? Yeah, negative 4 over 2. Again, it's still negative. So we get, like, yeah, we can easily eliminate a lot. What about this one here? If I sub in 0, it's 2, 4. Yeah, so this one's actually great because this one's positive. So we only get, now we've just eliminated, we just have 2. And let's think. Let's take another point. Let's say we take a point where the gradient is let's say we pick this point here. So, 2, 4. We can see at 2, 4, it's the gradient's like actually going vertical. So we know that the denominator should be close to 0. Let's look at the first case. So that point is 2, 4. If I sub in 2, 4 here, so 2 times 2 is 4, plus 4, 4 minus 2 to 2. Aha, this denominator actually becomes 0 at that point. What does that mean? I feel, yeah, it means that it should be like a vertical asymptote. So A looks very great. What about E? If I sub in, that'll be 4 plus 4. 2 times, so 8 minus 2. See, this one is wrong because, look at this, it's actually greater than 1. So it should look like this, so which is not. It's an actual straight line. So it's the only possible answer would be A in that one. So yeah, that's how you do, think about logically. But what about how to do it in like a second? Say in an exam, like a real exam, and this comes up in your, it always comes up in exam too. But let's think about it. How would you do this in like, I don't know, 10 seconds? Well, let's pick a point. Pick a point that looks great. So for example, let's pick 0 to -4. This point here. So when 6, so this point is 6, -4. And let's follow the path. Well, it's going like this. Follow those gradients. So it looks like this, moving like this, moving like this, moving. Let's move like this. It pretty much moves like this. So let's go on our calculator and go on menu and go to graphs and go to differential equations and write the expression that you think. So let's, for example, check A. Let's say we were checking A. So 2x plus y minus 2x. And the point that we picked was 6, -4. Enter. Aha, this is how our one looks like, our path. So that's great. So that it would have been A as your answer. What about we check, what about the other ones? Let's check one of them, just one case. Well, the second one is just x plus 2y, 2x minus y. And to that, aha, this here does not look good. As you can see, it moves like this, and that's not our path. Easy. Now, next question. Question 11. Consider the vectors given by A and B, where M is an element of all reals. If the acute angle between A and B is 30 degrees, then M is equal to what? Nice and easy. So we know that the dot product of two vectors equals the magnitude of A times the magnitude of B times the cos theta. So your actual angle between them, which is, in this case, it's 30 degrees. Okay. And so, well, let's do it by actually, let's do it by calculator because it's quicker. So, what's this question telling me? Let me delete this whole thing. And so, let's define those vectors. So, the first vector is M -1. B is the vector 1M. Okay. And so, we want the dot product. So, matrices. So, vector, we want to go to dot product of A and B should equal to the magnitude, which is, we call it as norm of A, times the norm of B, times cos 30 degrees. So we want to put 30 degrees, put the degree sign, enter, and we get this, and we solve, enter, comma, M, and we get two values. Let's write, those values down. M is equal to √3/3. M is equal to √3. So which one does that look like? Looks like C is your answer. But be careful. We have to check if that's true. Remember, there's a case that we need to think about. If the angle, in this case, it's between, if your angle is between 0 or like, pi/2, the dot product must be greater than 0. That's how you can check your answers. If the angle in another case is like, pi/2, theta pi, then the dot product must be less than 0. These are cases that you need to consider. So in this case, it's 30 degrees. So it is, we want the dot product to be always greater than 0. Let's check if that's true in this case. So if I sub in the first value, what was our dot product? Well, our dot product would be, so A dot B, be just M plus, it'll be M times 1, which is M, then 1 times M, which is M, hence it's just going to be 2M. That's our dot product. So if I sub in this over here, it's going to be greater than 0 because it's positive times 2. And also this one over here, positive times 2, also positive. So both our values are actually great. They meet the condition. So yeah, looks like C is your answer for that one. Great. Question 11. If the magnitude of A plus B is equal to the magnitude of A plus B, the magnitude of A plus the magnitude of B, where A and B are non-zero vectors, which of the following is necessary true? Let's think. Let's think what this is telling us. Say we have a vector that looks like this. It goes like this, and it's like, and this vector is actually A, yeah? And so we have another vector that is the same magnitude, so same magnitude, and this is B. Now, have a look. Is this case met true? I think this is how, okay, so the magnitude of A, so this magnitude, so the length of A plus the length of B, which is this, is equal to the length of A plus B, which, yes, if you add these two vectors, it gives us this vector, and, you know, finding the length should equal it. So that's great. So that condition we met, that's great. So let's think about, okay, so we have those. Okay, now this is what this expression is telling us. Which of the following is necessarily true? A is parallel to B. Yes, we can see that A are parallel. That's good. So that could be true. The magnitude of A is equal to the magnitude of B. Well, in this case, yes, that's also true. The vector A is equal to vector. No, that's wrong. Remember, vectors. These are, well, their magnitudes are equal, but the vectors are different. You can see that. Well, this starts over here. So remember that this one starts over here, whereas this one starts over here. So totally different vectors in a way. The vector A is equal to negative B. No. A is perpendicular to B. Nope. So it can only be A and B. Let's look at another case. Wait. We look at this one over here. The magnitude of A equals the magnitude of B. What about if I did something like, I'll rub this here, and I made it smaller. Made it, you know, this is your B. And so, let's see if that case works. So, the magnitude of A, what we're saying is the magnitude of A, which is this, plus the magnitude of B, okay, is equal to the magnitude of A plus B. Okay, yes. Certainly they are still, yes, that it does meet this condition, even though this is smaller. So B is wrong because we were saying that they have to always be equal, the magnitudes. So A is parallel to B is probably the best, yeah. That's always mostly necessary true. They have to be parallel for this condition to be met. Question 13. The position vector of a particle that is moving along a curve at a time, t is given by this, where t is greater or equal to 0, the first time when the speed of the particle is a minimum is what? Nice and easy. So we know that, okay, if this is a position vector, and if we find the derivative of it, we get the velocity. But we want speed, which is the magnitude of this velocity, and we'll get an equation, and then we just use calculus to find the minimum time. Let's do that in our CAS calculator. So we're going to say R of t. In this case, it's going to be, so 3 cos of t, 4 sine of t. Enter. So finding the derivative, so in terms of time, and we get this, and we want to find the magnitude, which is the norm. Answer, and we get this. Now we go to menu, and we want to go to calculus, and we want to find the minimum. So we go minimum, this, comma t, given that t is greater than 0, let's say it's, 0 to, 3 pi or something, but we only want the first time. So enter, and we get like 3 times, but we only want the first one, which is pi over 2. So question 13 is B. Nice. Question 14. The scalar resolute of A in the direction of B is what? Well, that's easy. It's just going to be the A dot B for the scalar resolute magnitude of B. This is your equation. So what is A dot B? In this case, A dot B is 3 times -1, which is -3, and -2, so it'll be -6, this one, which is going to give us -9. And the magnitude of B is what? So it'll be the square root 1 plus 4 plus 9, which is root 14. Hence, it's -9 over root 14. Let's also find the rationalizer. So we get Negative 9 over root 14 over 14. So which one does that look like? Looks like C is your answer for that one. Easy. Question 15. A constant force of magnitude p newtons accelerates a particle of mass 8 kilograms in a straight line from a speed of this to a speed of this over a distance of 15. The magnitude of p is what? Okay, so we want to find the force. Well, we know that force is mass times acceleration, the net force. Well, in this case, think about it. If we have the initial speed, which is 4, and we find the final speed is 20, and we know the distance, your displacement is 15, we can just use our constant, and we want to find actually the acceleration in this case. We can use our constant acceleration formula, SUVAT formulas to calculate that. So it would be v squared equals u squared plus 2as in this case. We'll use this. And so it'll be 20 squared minus 4 squared over 215. And that is going to give us our acceleration. So let's go on our calculator and write that down. So it'll be 20 squared minus 4 squared, 30. That gives us our acceleration. Now remember, it's force equals mass times acceleration to get the force. So we need to multiply by mass, which in this case is 8. And that gives me 102.4. So choose E as your answer. Nice. Question 16. The diagram below shows a mass being acted on by a number of forces whose magnitudes are labeled. All the forces are measured in newtons and the system is in equilibrium. Okay, so what does the equilibrium mean? That the net force is 0. Okay, the value of F2 is what? So, okay, let's break this down. Let's break F2, the force F2 down into its components. So we get this and that. And let's actually like equate all the, let's take up as positive. Let's take up as positive in this question. And we're going to equate all the vectors, like the overall total net force equivalent to 0, because remember the net force is 0 for the vertical direction. So in this case, we have this over here, which is F2, because it's positive, so I'm going to put a positive here. So F2 sine 45 degrees. Okay, that's good. And so that, and we also have this force here, which is downwards, and it's vertical, so it'll be -4. And we also have the component of this. So imagine breaking this one over here down, this one over here. So we'll get a downwards force. It will be pretty much -3 sine 30 degrees. And this over here should all equate to 0. I mean, the total sum of it must equal 0 because the net force is 0. So using our calculator, you can easily pretty much solve this. Let's do that using our calculator to calculate F2. So we're going to solve F times sine 45 degrees -4 -3 sine 30 degrees. That should all equal to 0, comma F. And we get F is equal to 11 root 2 over 2. It looks like B is your answer for that one. Nice. Question 17. A tourist standing in a busk of a hot air balloon is ascending at 2 meters per second. So imagine, let's say you have a box. Let's say that's the passenger, and a hot air balloon is going to look like this. And so it's initially going U at 2 meters per second. And we'll take up as positive, okay? The tourist drops a camera over the side when the balloon is 40 meters above the ground. So think about the path. So it falls down and it's going down. So now, because it's going down, displacement is actually going to be -50 because it's going down. Remember, the direction of down is what? We're only taking up as positive, so it'll be -50. Neglecting air resistance, the time in seconds correct to the nearest tenth of a second taken for the time to hit the ground. Okay, and remember, acceleration is going to be -9.8 because acceleration is always downwards. But remember, we're taking positive as up, so it must be -9.8. Now, using your SUVAT formulas to calculate time, let's do that. What is it going to be? Well, if we use S equals UT plus half AT squared, where S is -50, U is 2T, which we don't know, half A is -9.8, T squared. We use our calculator to calculate the value of T. let's do that. So solve. Negative 50 equals 2t plus 0.5 negative 9.8 t squared, comma t. We get two values of t. Of course, t has to be greater or equal to 0 because time can be, time can never be negative. So it must be this. So 3.4, which looks like easier answer for that one. Great. Question 18. A 95% confidence interval for the mean height mu in centimeters of a random sample of 36 Irish setter dogs is this. The standard deviation of the height of the population of Irish setter dog in centimeters correct to 2. So we want the standard deviation. Okay, let's think. Well, remember the formula for the 95% confidence interval. It's going to be, your, it's going to be, your sample mean minus that 1.96 because it's 95 s over root n, and that should equal, this one should equal to lower bounds, so 58.42. So just using that, well, the other cases, yeah, we'll use this, and we just need to, we know the n, we just need to find the sample mean. Well, it's easy to find the sample mean because there's a quicker way. If you draw a diagram over here, we know that mu, so your sample, in this case it's not a sample mean, is between this confidence interval, and they are equally, so this one here is 67.31 and this one here is 58.42. So if we add these two and divide them by 2, we'll actually get that sample mean. That's what we do. Well, yeah, I mean, there's many ways you can actually get that sample mean. For example, we can also equate, because we have two variables, so 1.96 s over root n, well, the other case, which is 67.331. And yeah, you can do use your calculator to do this. So let's do that. There's many ways you can. So we're going to go menu, we're going to go to algebra, we're going to go solve substantive equations, and we're going to try to find s and let's call it x here. Well, let's think. So we're saying x minus 1.96 times s is what we're trying to find. Root n, so our n value is 36, so the root of that is 6, should equate to 58.42. So taking this whole expression here and copying it by changing this to a positive and changing this to 67.31, answer, we get, this is your standard deviation, so 13.6. But we wanted two decimal places, so it's 13.61. So D is your answer for that one. Question 19. The gestation period of a cat is normally distributed with a mean of mu and a variance of this. The probability that a sample of 5 cats chosen at random have an average gestation period greater than 65 days is closest to what? So what we want to find is the probability that the sample mean, in this case, the average gestation period, must be greater than that 65 day. Okay, easy. Well, change it just to the standard normal is greater than 65 minus your mean, which is 66, because that doesn't change, divided by, now, okay, we need to find the standard deviation of this, which is just the square root of this, so it'll be 4 over 3, but you need to also remember the standard deviation of that is going to be s over root n. Our s is 4 over 3, and we're dividing it by, well, we have 5 cats, so dividing it by 1 over root 5. So 4 over 3 root 5. So here we want to put 4 over 3 root 5. And yeah, so that is what we're going to use to calculate. So using your calculator, that's what we're going to calculate the probability. So 65 minus 66 is negative 1. So first let's calculate what is 4 first. 4 over 3 root 5. We get this, and so 65, yeah, so that gives me this. We get that, that's great. And we also know it's negative 1, yeah, so negative 1 divided by this, which is that. So what we want is this over here to, okay, so we're going to go probability distribution and go to normal CDF. So we're saying this point over here must be greater than 0, where, okay, we're using the standard normal distribution, so we don't change those. Press OK, nothing happened. Let me try it again. So this goes to infinity. Press OK, and we get 0.9532, so which is E. Last question. The scores of a mathematical and statistics test expressed as a percentage in a particular year were both normally distributed. The mean and the standard deviation of the mathematical test scores were 71 and 10, respectively, while the mean and the standard deviation of the statistical test scores were 75 and 7, respectively. Okay, so assuming that the sets of test scores were independent of each other, the probability, so we want the probability that a randomly chosen math set, so a math test, that math test is higher, so greater than a randomly chosen statistics score. This. So we can rewrite this as m minus s greater than 0. So we need to find the mean and the standard deviation of this. To do that, it's very easy. Well, the expected value of m minus s is just going to be the expected value of m minus the expected value of s. What's the expected value of m? So the mathematics test. Well, we know that the standard deviation is 71 minus the the expected value of the statistics, which was 75. Hence, that's going to be -4. Done. The next part is we need to first find the variance of the m minus s, which is variance of m. But be careful, you don't want to write minus. Remember, the constants, for example, if this is -1, it gets squared, so it'll be plus the variance of s. So the variance of m is what? Well, the maths test is it's 10 squared, which is 100. And the standard deviation of the statistics is 7, so 7 squared is 49. Hence, we get 149. But remember, to find the standard deviation of m minus s, it's just going to be the square root of that. And we have everything that we need. So square root of 149, which is this. I'm going to copy that. And I'm going to menu probability distributions, norm CDF. And what I want is for it to be greater than 0, where this is your standard deviation. And your mean, for our case, is -4. Enter. Does not work. Let's try it again. Why doesn't it always work for the first time? So remember, this is -4. That's that. That's 0. And that's to infinity. And we get 0.3715, which is B as the answer for that one. And pretty much that's it. I hope you guys learned something through this video. Please make sure to like and subscribe to for more future videos. Please share this with your friends. And I hope you guys have a great day. Take care of yourselves. Bye.